It's looking dicey.
So if we're projecting B onto A, the first one, would that mean we write proj, PROJ, A and then the B?
So B onto A would be proj. What'd you say?
And the little A onto a B, or would it be a little B onto a B?
Yeah, that's right. So it's like that's going onto that one. Sorry. Yeah. Melissa, you do the first two with me. First one.
So the projection of B onto A.
Yep.
You have A times the dot product of A and B on the modulus of A squared times A.
Yep.
Put in the calculator.
The modulus of A.
So let's do a side note, maybe over here.
Modulus of A is the square root of 12 squared plus 6 squared.
Yep. So modulus of that.
Which is square root of 180.
Square root of 180. Sure.
Which is 6 root 5.
Which is 36 times 5. Yeah. Yes. 36 times 5. Yep. Yep. So I guess the fact that we're doing the modulus of A all squared, I probably wouldn't simplify that. I would just do the square root of 180 all squared. Honestly, I would just do it in one go as well. That's fine too. Yeah.
And then dot product of A and B.
Yep.
Is 12 times 6 plus 8 plus 6. 8 times 6.
12 times 6. So these two plus.
So I got 6 root 5 squared equals 6.
What?
Well, that's why.
Classic maths. So what does this one equal to in the end?
That goes to 72 plus 48, which is 120.
120. Cool. All right.
120 and 180, not 6.
It's looking a bit nice, isn't it? So A is this guy here, so 12, 6. And notice, they just keep in mind, they will give you things in component form. They will give you things in sort of column notation, either way, right? And that ends up being quite nice. That's just 2/3 of all of these, which ends up being 8, 4. Is that right? Yeah, cool, perfect. Let's check out the other one. Just need a bit more room. And the good thing about doing it the first time is that now you have actually all the information you need, right? And just to keep in mind, they give you this formula here, right? And they tend to, it depends on which textbook you look at, but they tend to sort of maintain the order, they sort of maintain that consistency between the order of what you're given. It doesn't matter, because the dot product is commutative, so it doesn't matter what order you do it in, but they may write it like that, just keep that in mind, but it means the same thing, right? And the good thing is we already have the dot product. What we do need though is we need the magnitude of B all squared. Josh, can you help me out? What's the magnitude again? How do you find that?
Sorry, just clarifying.
Yeah.
With the proj A, B one, the one we just did.
Yeah.
So we wouldn't put that in the IJ form.
I just like column notation better. Like, probably what's best to do is probably to do what they've given you. That's probably the best thing to do. But I just personally prefer column notation. That's why I tend to write mine in column notation. But either way, it should be fine. Yeah.
So is it fine to just change it in the middle of the question?
Look, I can't see a problem with it, but I will check up on that if that's going to be an issue or not. Yeah. But yeah, magnitude of B, Josh, help me out. So this one here, what's the magnitude of B? How do we find the magnitude again? Do you remember?
Oh, yeah. So that would be the square root of 6 squared plus 8 squared squared.
Yep.
Which would be 36
Okay.
plus 64.
Is 100?
Yep, bang on 100 or 10.
And then
it's squared anyway, so it stays 100.
Perfect. Okay. And let's put it all together. Yeah, and we have that up here, don't we? 120 on 100 multiplied by vector B, which is going to be 6, 8. And what do we get from that? What does that end up being?
It was like 7.2.
Oh, so that one's the nasty. Is that the nasty one?
9.6. No.
Huh?
I don't know whether I did it wrong, but there's like on this side.
Yeah.
I ended up with.
I don't know if those examples are the same.
33 over 73, negative 888 over 73, and then for the other one, there's negative 500.
Wait, these are different ones. These are different ones, right? Yeah. What about this one over here? What does this one end up being?
36 on 5, and then 48 on 5.
And that simplifies to 7.2996.
36 on 5 and what was it say?
48 on 5.
48 on 5. So the takeaway is that sometimes the numbers will be nice, sometimes they won't be. That's kind of up to the question, really, how nice they're going to be. It is hard to make the examples actually whole numbers though, so let's have a look. And what would we say? 8-4, was that one of ours? Bing! Hey, it did work out, right? So, that's, do the,
Yeah, let's do it.
I can't reverse the projection on this one. I have to literally manually reverse it.
Yeah, we'll manually reverse it.
Yes, Mum. Yes, Mum. What was it? 12.6?
Yeah.
Is that what we got? 7.29.6. Yeah, there you go. Awesome. Cool. So that's vector projections. Great. How do you feel about that? You don't like the numbers?
I mean, isn't the male species
Wait.
like...
You know what you need to do then, Cameron? You need to come up with better numbers for me.
Can I just because they have the same denominator, can I just...
You can factor it out. You can actually, yeah, that's fine. Actually, that's what I should say. For this one over here, what we can do is if you want to write it a bit nicer, just write it over here. You could actually factor out, 1 on 5, and you'll get 36 and 48, which might be a bit more helpful, but again, these are the same. Yeah. As in these two are the same here.